Let's see. I think it's
recording.
It's on. Yeah.
Okay, good. Then I will start. So good afternoon, everybody. Well, it's strange to say everybody because I don't see anybody. But I hope you're all doing fine, despite being locked up for almost a year and a half now. But in those past 18 months, you probably consumed a lot of food, and you probably bought more food than you did before because the restaurants were closed and canteen, of course. So in doing that, you probably also purchased a lot of packaging. And that's what I would like to talk about this afternoon. Because in my work, as part of my work, I also do a lot of work on how can we reduce the environmental impact of packaging. And I will explain why that's important in a minute. First, a few words about myself. I'm a professor at Utrecht University in Energy Resources and Technological Change, which is a mouthful at the Copernicus Institute for Sustainable Development. I studied chemistry myself, actually in Utrecht, but after my PhD in Utrecht, I moved to the US. First, I spent a year at Princeton University. Then I went to one of the 12 national laboratories in the United States, in Berkeley, California. Just a nice picture there. In the middle, that is Berkeley Lab. You overlook the Bay Area. So from my office, I had a view on the Golden Gate Bridge. And then I moved back to the Netherlands, where I first started working for a consulting company. So I changed my view from the Golden Gate Bridge to the Praxis, the store, which was not, of course, an improvement. And then after working for a couple of years in consulting, I became a professor at Utrecht University. So I don't have a typical career in academia, and that I think that also tells you a little bit about how I approach things, and what you'll hopefully also see later. In my research, what I focus on is really trying to understand how we produce materials or how industry works. And most of the energy in the industry goes to making materials. And how can we do that with less energy and therefore reduce climate impacts and also less pollution? And at the same time, also looking at those materials are manufactured into products and we consume those products. Can we do something to reduce the need for those materials or move to more environmentally friendly materials or design products in such a way that they need less materials? And that's what this last topic is about, for instance, now focusing on packaging. So why packaging? Well, first of all, I'll show you this picture and ask the question, what is wrong with this picture? This is a packaging you could purchase in Albert Heijn. Well, what's wrong with this picture is that it contains 25 grams of fresh herbs, and for that, the container weighs 30 grams of plastic. This is just, of course, insane. And you think, well, this is just a example, but you just go to your local supermarket and go through all the different packaging, and you will be surprised. And of course, there are some very bizarre examples out there. This was a supermarket in Austria which introduced pre-peeled bananas. I mean, I don't know how you make it up, but they did. And this, of course, this became an international story, international headlines, because, I mean, who's going to unpeel a banana? Banana, of course, is perfectly packaged by nature itself. You're going to unpeel it, put it in a plastic box. And then here, this is in the United States, avocados, because a lot of people apparently hurt themselves with cutting an avocado. So they do the cutting for you and put them in plastic with paperboard around it. And another example here, these are unpeeled oranges. So you can see out of these examples, we do a lot of funny things around packaging food, and all under the name of convenience, or sometimes to retain freshness and other things. But at the same time, we use huge amounts of materials for that. And that produces a lot of waste. This is packaging waste per person in in different European countries. This is a little bit older data, but what you see here, all the countries, the amount of packaging that we consume per person is going up. And at the same time, packaging is about 36% in Europe, about 36% of all the waste that we produce. So it's a large generator of waste, and therefore, of course, also a large user of materials. And also, although a part of that is recycled, here you see Netherlands, we have a relatively, so if you look to Europe, we consume a relatively large amount of packaging materials, yet we also do a lot in recycling. So you would think, well, that's good, that's not that bad, isn't it? Well, I will come to this recycling later on in the example, in discussion about plastics, for example, because recycling is not necessarily what it is, what you think it is. But this shows you the problem. And so there are countries that consume more packaging material per person per year, but there are also countries that consume far less. So here there are things that we can learn. And how can we then improve this? But still, this is a large amount of material that we consume on an annual basis. And these are pictures from, these are all examples of food packaging. These are pictures from a French photographer, Antoine Repessé, and he made a series of pictures called 365 Unpacked. So he had households and people collect all their packaging waste for a year. Then he took pictures of them with this with all these packaging materials. And so here you see the bottles of water and energy drinks, cans, all kinds of other packaging. And you see this, and if you would just save up all the material that you use in a year, this is what you would get. And that's what I like about these pictures. They really show you, the size of the problem, the little size of the problem. But because we throw them away, or we recycle them, or we bring them to a container to be recycled, we don't really see it. But on an annual basis, it's a very large volume of materials. And that, of course, results in this growing mountain of waste. And this is all plastic waste. It results in littering. And littering is actually it's a big problem for many reasons. Of course, it's not nice to look at, but these plastics, they, under the influence of UV light, they fall apart into smaller particles, and those smaller particles may end up in organisms. Of course, they all end up in the water, and then they come and they sometimes they're filtered out before they enter the sea, but a lot of the stuff enters actually into the rivers and ends up in sea in what we call the plastic soup. And this is a picture of the plastic soup. Plastic soup it's in the ocean. In the Pacific Ocean, for example, there are what we call patches, and the patches is a huge area because of the streams of the water. That's where all the material is collecting, and and then we also found these patches on the Atlantic Ocean. So this is where basically all the plastic is coming together, and this is how it looks like. So it's a very fine distribution of plastic over an extremely large surface area, and there are estimates that there are each of those patches contain about 5 million tons of plastic that's spread out over a huge area. Of course, and this enters the food chain. So this enters into fish, and in fish into birds, from fish, of course, into us. And also under the influence of UV light, these things, they may fall apart in what we call microplastics. And microplastics can, this is what you know, the famous Japanese drawing about the wave. Well, this is an Italian artist who made a caricature of it with plastic waste, because this is basically what's going on. And some studies, they have estimated, and of course you have to take them with a grain of salt, that if we continue like this, by 2050 there will be more plastic in the ocean than fish. So that is a tremendous problem. And also, these microplastics, the microplastics, they can develop, or basically because of plastic falling apart, and a lot of plastic waste found in the ocean is packaging waste actually, but also fishing waste. But they can also be made on purpose. So in a lot of cosmetics, like scrub, there may be microplastics. That's what you see here on the finger. So we also make microplastics on purpose. And these microplastics are not filtered out in the waste management or the water treatment system, the sewage system. So they actually end up in the ocean for a large part. So, and then this is the example of plastics. And of course, you can discuss also other packaging materials. But plastics, of course, is one of the areas where there's now a lot of attention, also policy attention. Because also what this picture shows you, we started really making, the first plastic was made in the 1950s, actually invented by a Belgian guy in the invented Bakelit. And from then on, packaging or plastic production has really increased. And this is a picture that shows you the amount of or the different uses and how much plastic has been produced over the years. And you basically can see here that 40% worldwide of all the plastic is used for packaging. So this is the one reason why packaging is so important. Also from a policy perspective, because for instance, the European Commission now announced has introduced actually the Single-Use Plastics Directive to reduce a lot of the single-use applications of plastics. And that is, and they look at, for example, at those materials that end up a lot on the beaches. So it's cotton swabs, but it is also plastic bags, of course, to move away from single use, because that's basically what the industry for a long time has promoted. And we have to now move away from it to reduce this important part of the plastic consumption and plastic pollution. Now, and then I mentioned recycling before. So this is from the Ellen MacArthur Foundation, which is it's a foundation which is trying to introduce or help to bring about the circular economy globally. And they wrote a report about where they estimated they came to an estimate about 78 million tons of plastic was used in packaging, which I think is an underestimate. But 78 million tons of plastics are used on an annual basis for packaging, and then you can see what happens with it. Well, still a large part goes to landfill. About 42% of it is leaking, and leaking means that it enters into the environment where it's uncontrolled, and notwithstanding that landfilling is also not necessarily controlled. And this 32% basically that becomes then litter, and that may enter the oceans, become part of the plastic soup, and actually may become part of the soup that we eat. Then a large chunk is landfilled still, because most countries around the world they landfill the materials, including plastic, and plastic in a landfill will basically last forever. It will slowly fall apart in smaller particles. But yeah, the plastic that was landfill 20 years ago or 30 years ago is still there. And then there's a part which is incinerated. I mean, in Europe, of course, and especially in the Netherlands, we incinerate a lot of our waste. So also plastic. And there, of course, if you incinerate plastic, you basically generate carbon, CO2 emissions from fossil fuel, because 98% of all plastics are made from oil. So that contributes then to climate change and also, of course, to air pollution. So here you see globally about only 14% of all the plastics from packaging are being recycled. And if you then actually see what's happening with that, only 2% comes back as packaging. 4% of those 14% is 4% points of those 14% are basically lost again, because they are such a low quality that they cannot be recycled. 8% becomes something else. And that something else, you have to think about, for instance, the little dark black holes along the highway. They're made from waste plastic, recycled plastic. So it is a kind of recycling, but typically we call it downcycling. Because if it's really recycled, it should come back for the same application, which here we see only 2% of all the plastic worldwide comes back to become plastic packaging again. So that's the problem. So even though when you saw the numbers of the Netherlands where we recycle a lot, only a very small share comes back into packaging again. And that only applies basically to the PET bottles for now. And this is something that we should improve. If we really want to recycle these materials and not just downcycle them into another application, we really have to up our game, as this graph clearly shows. So that's a problem. So, and that's also what this drive is. How can we move from a linear to a circular economy? Because here, basically, if you look at the previous graph, the majority of the material is flowing one way. We extract the oil, we make plastic out of it, and we make a plastic product out of packaging. In this case, the packaging we consume with our things that we buy, and we throw it away. And only a very smart or small part comes back in some form or the other. So the idea of a circular economy is that these loops are closed, and there's no leakage or no losses anymore to landfill incineration or leakage to the environment. Of course, in theory, that's a nice theory, but in practice, it's virtually impossible to do it completely. So there will always be some losses. But the idea, of course, is it leads to reduce those sizes of those outflows here on the right and make the recycling loop or the reuse loop much bigger. So we want to move from this current linear system where we have raw material, making a package out of it, we consume it, and we throw it away. We want to move to what we call a circular system, and there are different ways to close this circle. So after disposal, we could recycle the material and we make it back into a raw material, and we make something new out of it. But one of the smaller loops is also this loop in the middle. That is actually, we can make something reusable. So then we don't reuse just the material, but reuse the whole product in the shape it is. And of course, when you think about packaging, the brown beer bottle is the prime example of that. That bottle is washed. Again, after you brought it back to the store, they wash it and they put new beer in it, relabel it, and you can probably, there's chances you get exactly the same bottle back again. But there are, of course, many more examples of that. So there are different ways, what this graph shows you in this case of capturing, there's different ways to close the cycle. And for that, within the circular economy world, they introduced this, what they call the R strategy ladder. And there are different ways of doing that. And then the best thing you can do is to refuse a product. If you don't make it, it will never produce waste. And think about the bananas. I mean, pre-peeling a banana is just a bad idea. So refusing pre-peeled bananas would be the first thing to do. But the other things you can do, you can rethink product. Can you make a different? Can you a product provides a service? Can you provide that service in a different way? Or you can provide the same service with using less material, and that's R2 reduce. And then we have this whole range of here, it's R4 through R7 basically, that's about how can we use the product that we have in a better way. I mean, can we reuse it? Can we repair it? Refurbished phones and computers are examples of this as well. And then on the lower part are the parts where we call recycle or recover, and this is basically where we reuse the materials. And what you now see, there's still a lot of attention to recycling, but if you look to this ladder, and basically it's in hierarchy, so the higher up, the better it is viewed, and it may not necessarily be always the case, but at least it's viewed as a better solution, because you retain more of the value, or you save more, or you reduce the environmental impacts more than with measures which are lower in the hierarchy. Well, they have a higher R number, they're lower in the hierarchy. So give you a few examples with regard to food packaging, or reviews that are the R0. Or demand reduction, of course, the key example is the banning of plastic bags. Here in the Netherlands, also a few years ago, they banned the free use of plastic bags, and you have to pay for plastic bags. And just a few weeks ago, Albert Heijn, of course, took away the still free plastic bags in the grocery department. So now you have to move to reusable bags. But this is a movement that actually started in some cities in the United States already about 20 years ago. And very surprising, very interesting, especially, is that it also started in some developing countries. One of the key countries actually leading this effort is Rwanda. And Kenya is also, but also other countries, especially in Africa, has been really illustrative examples in this. And why was that? Because they lack a good waste management structure. So the plastic bags ended up everywhere, and they were blocking the open sewer systems. They're blocking rivers and small streams. And Rwanda is actually one of the most strict countries. So if you you get very high fines if you would still provide a free plastic bag. So there, and what we see from the industrialized countries where we have a lot of monitoring, we see reductions in the use of plastic bags by 90+%. And that means a lot of reduction in waste. Estimates of how much we used in plastic bags in the Netherlands was about 25 to 50 kilotons of plastic on an annual basis. So this is an example of refusing things. These are examples of rethinking. The left examples are some more like food-related examples. But basically, you see the same bottles. They contain the exact same amount of product, but they consume much less glass or plastic. Or in the case of this McDonald's thing, they moved from polystyrene, which is hard to recycle, and it's plastic, moved to cardboard, which is biodegradable. And of course, in toothpaste, we kind of got rid of the box. Although in the past few years, you may have seen this, the box is coming back, which is insane, to be honest, that this is happening and that we allow this. And the right example is although it's not food related, I really love this example because it shows you with a little bit innovative thinking how you can make some drastic changes. This is what we call kind of a blister packaging. So there's a large amount of packaging material to package a relatively small product. And here you can put them in a rack. And here this is paperboard and with plastic around it, and that is the glue stick. And what they did is they just made a little hook on top of the glue stick instead of this whole packaging, and you can still have it in a rack, so clearly visible for consumers, and you save a huge amount of material. So I like these kind of innovative examples, and there's small examples, and it takes a little bit of creative thinking, but then you can come up with these things. And then there's also another thing of rethink, and that is the idea that can we use biodegradable packaging materials? Well, the first thing I need to say, and I think this is really important because you hear a lot of things in the media and also about bio-based plastics. So we make plastics out of bio-resources, but bio-based is not necessarily means biodegradable. There are some bio-based plastics. There's like, for instance, in Brazil, there's a factory that makes PET, so which is make the bottles that the soft drink bottles are made from PET, which is made from bioethanol. So it is bio-based, but a PET bottle, even if the PET is made from bioethanol, is not biodegradable. There are some specific bioplastics which are also biodegradable, and one of them is polylactic acid, or PLA, which is one of the most used at the moment. But it can only be labeled biodegradable if it disintegrates, and there's these European standards for this, and you can read it. But basically, the material should disappear within about 6 months, and these are numbers for industrial composting facilities. But here we also see a problem because here say 3 to 6 months, basically the whole thing is gone, and less than 10% of the particles which are remained are smaller than can be above 2 millimeters. But in reality, most industrial composting installations they process the bio waste in 2 to 3 weeks. So most of the biodegradable materials are not yet fully degraded. So they would need extra steps, which the current process is not done. And also, some of these biodegradable materials actually do not degrade in other environments. For example, PLA does not degrade in the marine environment. So PLA could still contribute to the plastic soup or end up in animals, because if it's on the ocean, it ends up in the ocean, it just will not degrade. So for some things, so for some applications, biodegradable may be an option, but then we really need to rethink what biodegradable means, and we need to really have biodegradable materials that fit into the waste management structure, and they currently do not necessarily do so. Another thing what we see a lot is that there are a lot of small changes made in packaging, and this comes from a paper from a number of years ago, where we looked at a couple of hundred packaging. Every year there are thousands of new types of packaging introduced. And out of those thousands, we found about 200, if I remember correctly, that actually were doing something to make the packaging more sustainable. And these were kind of the actions were taken. They were either increasing the recycled content of the packaging material. They used to move to refill, but what we mostly see is lightweighting. So, and that's especially in plastics. So basically, we're starting to use less plastic to packaging the same amount of product. And that there, for example, a couple of years ago, one of the supermarkets, they had these plastic containers for strawberries, for example, and they replaced the top part with a film, and that's lightweighting, because then instead of having this more heavy cover, it's now just a film which can be removed and weighs far less than the original cover. And there are many examples of those, and that's what we see in practice that most industries do. So these are really small changes. They're not the big changes that we need if we look at the size of the problem. So that's why we're also looking at other changes. And before I go there, maybe this is a good time to see if there are any questions or discussions. I'm for discussion. You can open your mic if you want to ask a question at this moment.
Yes, indeed. So, are there any questions? I have some questions. I don't know why I can hear myself. Okay, so if there are no questions from the students, maybe I can ask you something else that I was thinking. Mm-hmm. The students now would have to create a solution for a mobile, let's say, food concept. So if soldiers go to different countries or to different even cities for their trainings or for missions, then this kitchen and the whole system would need to be transferred. So that would mean that maybe different legislations or different measures need to be taken for the recycling of this packaging in each station. So I don't know if that actually has an impact in what we're discussing now and what maybe they need to think when they're in their solution.
Yeah, so I don't know what this particular concept they're now working on, how it is consumed by the military, because if it's consumed on a basis or one site, and then you could imagine that there could be ways to make it reusable if you have, depending on how you organize your supply chain. Although if you have to transport something over long distances, then what we come back next to is reuse, may not always be the best solution. But the problem also I see is that there may be a lack of a waste management system. And so the first thing to understand is how is waste management at those military sites? And if it is used, I mean, and the other thing, there are also these emergency meals, or these personal meals, which soldiers they use wherever they are based, and they eat them wherever they are. Yeah, of course, there's no waste. There's nobody driving behind them with a waste management truck. So they throw them where, and yeah, that maybe is one of the specific things where you think, well, maybe the biodegradable isn't that an option for this particular application. But that really depends on, of course, you need to understand how the food is consumed and how what the role of this packaging is to figure out what will be a more sustainable solution to deliver the food.
I see. Thank you. There's a question from Mayur. Mayur, would you like to ask it yourself, maybe?
Yes, thank you. Yeah, I wonder if like end users have to wash containers when we throw away if we want them to be recycled. Because for the very clean, I mean, I think everyone like separate them, but when the food is still on the packaging, maybe some people just throw it away as a rest.
Yeah, that's a very good question. And in the Netherlands, let's say in the Netherlands, the system varies by city, how waste is collected. And that makes it a little bit confusing to some people. So, but in some cities, or most places, I think now, the plastic is collected together with cans. It's called a PMD fraction: plastic, metals, and drinking containers. And then what they basically say, you do not need to clean the plastic. But of course, if it contains still a lot of food, and you throw it in a fraction between plastics, and there's also paper in it, because in some cities like Utrecht and Rotterdam, they do after sorting of the waste. Yeah, if there's still a lot of food in there, then actually it may contaminate the whole recycled fraction. Because you can imagine if there's still like yogurt in one of those drinking cartons, if that comes out, it may, if there's paper in that fraction, the paper will absorb the moisture, and you can just throw away that paper. It's not recyclable anymore. So in practice, I think if it still contains a lot of food waste, then throw it just with the residual waste, because actually it may lead to that one whole big container is just said like, oh, it contains too much other stuff, and therefore it's not considered recyclable. So that's a little bit of the more difficult answer, but basically if there's still all food in it, then please throw it in residual waste. If there's just a tiny amount of it, don't worry. and just put it into recyclables, because the materials are being washed, especially if the plastics in the cans, that's not that important. For paper, it is of course important, because paper absorbs the moisture from the food, and then you cannot use it anymore. Does that answer your question?
Yeah, thank you.
Okay, you're welcome. Okay, shall I then continue?
Yes, please. I don't see any more questions for now, so maybe we can continue.
Good.
Great.
Okay. So then I want to move to this picture, and I was asking you, can you see? I mean, normally our class, of course, this will be have more interaction. Can you spot the difference between those two bottles? And they both contain 1 liter of the same apple juice. So in the product that you consume, there is basically no difference. This is FlavoSop. It's a small apple juice producer, although you can find them in Albert Heijn and Jumbo and other supermarkets. And when you go to Albert Heijn or Jumbo, you will find the bottle on the right. That is a single-use bottle. And although on the website they tell you a lot of nice stories that you can make it into a vase to put in flowers, some all kind of other stuff, but basically that bottle is you have to throw it away with the glass fraction, and then they will make a new bottle out of it, but that still consumes a considerable amount of energy. And the bottle on the left, this is actually the bottle that Flavor Stop started with, and that you can still get through smaller shops, especially in the area where the factory is located. And that's a reusable bottle. So this bottle is being washed and used multiple times. And we know, for example, we don't know from Flavor Stop how often these bottles are used, but from Heineken, the brown beer bottle is used actually between 25 and 50 times before it's lost. So you can see that the left-hand solution in itself will be more, at least from a climate change effect, will be more beneficial, because although you need to clean the bottle, you have to and you have to transport it back. As we see later, that has a smaller impact than making a new bottle. It's on the right. So why does Flavor Stop do this? Well, probably because those big supermarkets, they don't want reusable bottles. And so they want the single-use bottle on the right. And if Flavor Stop wants to sell it through the supermarkets, they have to offer this opportunity or this option. Otherwise, the supermarkets may not sell their bottle. So one of the things that this thing triggers us that we want to look at is trying to understand what are the opportunities for reusable containers in our code for packaging. The Single-Use Plastics Directive also has come into force in the meantime, and has really shaped this discussion as well. And there's now much more political force to implement these things. So what we're starting to do, trying to see, what's going on in reuse. And because there are a lot of new, because of this whole discussion about plastic waste and all other kind of discussions ongoing on sustainability, we see a lot of sectors now looking into other options to find alternatives to the current packaging systems. And these are some sectors we find them in logistics, also in e-commerce. Well, you probably the past 18 months you also ordered a lot of things online. Well, you know how many boxes you may end up with and how much other materials in those boxes which are used to package a small thing you ordered. We see a lot of unsustainable kind of way of packaging today in all these areas. But we see all in these areas also the new alternatives being developed. So in these logistics, e-commerce, food and beverage, especially in cosmetics, there's a lot of things interesting going on, cleaning and hygiene products. Also in furniture and in bulk packaging. These are all kind of sectors where we see a lot of initiatives for reuse. And we see this also happening worldwide, not just Europe, where we have the Single-Use Plastics Directive, but we see these new initiatives and startups developing around the globe. So they're really starting to address a global problem. And this shows you, this is many examples that we collected over the past few years. On LinkedIn, we have a page where we collect all these items, these suggestions, and that's helped us to build a whole network of companies around the world, again, that develop reusable packaging systems. And to give you a flavor of those, so based on all those different initiatives, we kind of developed what we call a classification system for this. We call something we call zero waste options. Those are options basically you take away the packaging, or you can take the packaging to a shop and refill it there. Lush, for example, they make soap in there, but you can basically buy soap without packaging. But also EcoFair, they make detergents, for example, and other hygienic products. There they have they start to refill these refill stations. So you buy once a container and you can refill it in the store as many times as you want. And then are those things where you have a parent packaging and you can buy a refill fraction. And the refill fraction may still be packaged, but the parent station that is reused many times. And there are examples like this, especially in the hygienic industry, where like this box here from Rituals, the outside box is night box you have at home, and then you buy a very simple container with the products. So it's not completely reusable. Only part of the system is reused, but still it saves a lot of material. And then we have called returnable systems. So I already mentioned the beer bottle, but that's one of the famous examples, of course, is these bottles are being washed again and reused. And those same things are now expanded to other markets as well. And this is, for example, manufacturing using aluminium cans for detergents, for example. And then in the business-to-business market, actually, there's been already a large use of reusables. There are these containers. The Europool is one of the things they make these. They share pallets, the pallets which are reused underneath for trucking, for example. But there are also these plastic containers for fruit, which are reused. And that's also happening on a global scale. And they're also pooled in one large pool. So they're standardized and used throughout Europe, for example. And but also in B2C, business to consumer markets, there are these examples. This is for e-commerce. This is Repack. This is a Finnish company, and they make an envelope for which when you buy stuff from internet, clothing, for example, they are packaged in this envelope. You can, if you want to send clothing back, you can use the same envelope, but you can also return the envelope by mail, and then you get a discount check for your next purchase, and that's how these systems they get basically reused again instead of using what we call a poly bag only once, or using a cardboard box only once. And there are two other things in here. So on the left hand, the two systems, basically this is taking action by the consumer. They wash their things if they need to wash, clean something, or they have the refill station. And on the right hand thing, that is a system which is completely organized by industry. And to give you some examples. So in zero waste, the bulk systems already mentioned, EcoFair, but there are all kinds of other systems out there. And as to dispensers, there are stores. Miwa is a Czech company that offers this, but there's also stores in the UK called Unpackaged, where nothing is packaged, everything is in bulk, and you can fill your own container with that. And also you can find it also in US supermarkets, for example. And an example here is also Peter Pot. They sell everything in glass pots, which are refilled. Then the parent packaging system, there are done, of course, a lot of action in cosmetics, because they're also, image is important, marketing image, so that's why they like these things. But we also see them in cleaning and detergents, for example, systems, where you basically, you buy one package you can use and then have those refills. Returnables, again, a lot in cosmetics, but here we see a lot of action in the food and beverage. And here you see a whole range of startups, so where you can basically, you return your bottle after you use your container, and then they're cleaned up and they're reused again. And it's also done, of course, for crates. And there are also now a system called Loop. It's an American manufacturing company. They make it also for food delivery. So they got metal containers for ice cream, and everything is completely reusable. And with those food delivery systems like Picnic, for example, they come really to the client. So they pick up the same thing, and it doesn't really have much more environmental impact to transport these things back. And then make them suitable for, or clean them up and reuse them. Yeah, and then transit packaging already, here are some examples. The crates, of course, the pallets, which are used also in IBCs, intermediate bulk containers. But here are some examples for furniture, for example, or for appliances. The one on the right hand, if you ever bought an appliance and you know how much cardboard and polystyrene you ended up with, and these systems here actually they protect the product much better, and they can be reused, so you don't end up with a huge amount of waste in your place. And most of these machines are actually now being delivered to your home and installed by the retailer. So the retailer also has in this way you basically already have a closed loop logistic system. You only need to bring it back. And then e-commerce, already here's a number of examples which I already mentioned. Let me continue for the sake of time. What we did, we looked at all those systems and we looked at trying to identify, have there been studies that looked at the environmental impacts of these studies to understand if these systems are truly more sustainable? Because you saw some examples where you could, you still have your refill packaging. How sustainable is it? Or I need to transport it over long distances. In this example of the military that you're working on, if those military are stationed far away from the place where this packaging is produced or this food is produced, then you've got very long supply chains, and then transport over long distances may consume a lot of energy, so it may not be good for the environment. So what we try to understand is, have there been studies that looked at this? So we looked at the studies around the world, and we started to analyze those studies in a lot of detail. And we found a number of studies in these different numbers here for returnable. Mostly were on returnable or transit packaging. A few on zero waste. We did not find any studies that looked in detail at the environmental impact of refillable or parent packaging systems. And we found them business to consumer and business to business markets. And also found them all different places. So we find them for bottles. Most of the studies actually looked at bottles, but also crates and dispensing systems, food containers for takeout food, for example, cups, famous coffee cup studies. This gives you an idea that there are many developments out there which are also being studied. And so what we did is we tried to analyze all those life cycle analysis and trying to understand what would drive the impact. But the first thing we found is that about 3/4 of the studies that we found, that were studies done over the past basically 20 years, 3/4 show that the reusable packaging has a lower impact on the environment. And 1/4 shows either mixed results, so it really depends, for instance, on transport distance. And those factors may or may break even the impact of single-use versus reuse. And a number of cases where actually the single-use packaging was better for the environment. So then we started to understand, so which factors then are important? And this may be helpful for your project to understand which factors are important that drive, that make a reusable system more sustainable than a single-use system. And here again, you could see the circular chain. So we started the key aspects. Well, what are the key aspects? Well, it's the number of rotations. So how often is a packaging, a container, a bottle being reused? The more it's reused, the better it is for the environment. Then the other thing which is important is the material which is used in the packaging material. Basically, most of the reusable containers, they are thicker, they're heavier, so that might be negative compared to single use. But because they're heavier and they can actually contain more recycled material. So the recycled content in the container is an important factor. And then the distance traveled. If we have to bring back the empty container over a very long distance, and especially if it involves trucks or cars, road transport, that's very energy intensive. So over very long distances, reusable is not good. So for example, in the wine industry, if you consume wine in the Netherlands from France, it may still work. But if you consume wine from Chile or from Australia, it doesn't make sense to do that in a reusable bottle, because the transport distance, the energy that you would use to transport the bottle back to Chile or to Australia are just so huge. And also, the energy that we need to clean the container or the bottle again when it comes back to us. And some materials are easier to clean than others, like stainless steel or aluminium is easier to clean, glass. And some of the plastics actually have a problem. The plastics, they may absorb some of the flavor, but they need a deep cleaning. And that may actually then consume more energy. So these 4 factors, they really determine if reusable system is better than a single use. And then when you think about the case that you're working on, then we need to understand is how is this whole logistic, how's the supply chain organized in the military, both of getting the food to the military stations wherever they are. And I mean, and most is consumed in the Netherlands or in Europe during exercises, and only a small fraction is consumed in places like Afghanistan or other places where the military may be working. But trying to understand that is important because then you can see if for some part of this whole system, a reusable container may be an interesting example. And actually, this is a funny thing to think about. But if you use single-use containers, you also leave and you can throw them away after use, and you leave traces. And so it was really funny. Once I got one of those rescue packages from the Dutch military about 20 years ago, and the toilet paper was olive green because, well, just go to the forest, you can see the white toilet paper easily from a distance, so it's easy to see if people have been there, and so that's why they used olive green toilet paper in what was in the box with the food containers to at least that you don't leave too much waste. And also all the containers, there were cans with cheese, they were olive green for that reason, that they're not easily found, they don't are that obvious as a trace when you're operating in the field. Yeah.
There are two questions from students.
Sure.
Should we address them now? Okay.
Yeah.
So the first one is from Victoria. If a plastic alternative is home compostable, is it a circular packaging?
Well, that's a very good question. If you look to the different views on the circular economy, then by some it is seen as circular, because if it's compostable and it comes from a bio-based resource, basically it becomes biomass again and can be and then, but of course it's a very long chain, because then first it needs to be composted, then you need to use the compost again to grow something, and then it comes back. So from that perspective, it is indeed seen as part of a circular solution. But then you have to make sure, of course, that it is really biodegradable. And then, of course, you may still have the issue is, does it make sense to make it biodegradable, or is that really the most sustainable solution? And because if some of those reusable containers are used 50 times, then that may be a better solution overall than making this compostable packaging material. But of course, there are some applications of packaging that are hard to reuse. For example, where they have developed some single-use things like the geotextiles. That's not a packaging application, but geotextiles are used in terrain to keep this when the plants are starting to grow, like on a dike, for example, to make sure that the dike doesn't collide until the plants have grown and the root system control erosion. And that plastic would have been there forever, and that makes sense to make biodegradable, because then at some point, by the time that the plants have grown, it is part of the biomass. And there have also been the things where, like, especially for applications where which are on the go, and where they are used in a place where there's not a good waste management structure and they're not collected, then this could still make sense. So that's a long-winded answer again, but I hope it answers.
Thank you. And one more question from Hannah. PLA is less strong than regular plastic. Are there any innovations that are more sustainable than plastic, but just as strong?
Well, yeah, because of all the pressure on plastic and the problems with plastic, the microplastics and the plastics soup and all that kind of stuff, And also based on the problem with climate change and the role that plastics play in there. Yeah, although most of the emissions from oil are of course based from transport-based emissions, still 20% of all the oil is used to make chemicals. So people are looking at other bio-based materials and also other biodegradable materials. And PLA is one of the most used ones at the moment, but indeed it has some drawbacks compared to other plastics. So people are looking for other bio-based materials and also other biodegradables that are stronger or better or easier to degrade in different environments. So there's like HBA and a whole range of them. So there's a lot of research going on worldwide to look at alternatives that are better suited for different applications. And also there's a Dutch company called Avantium. They make a chemical called PEF, and they're building a first factory for that right now. And PEF is a bio-based alternative to PET. So it is actually as strong as PET, if not stronger. It can be recycled. It's not biodegradable, but that's a bio-based alternative to PET, which is now becoming one of the most used plastics in packaging. So there's a lot of research ongoing to develop new bioplastics because of these new pressures on the way that we now currently make and use plastics.
Thank you. Yeah, I think it is answered. I don't see any more questions, and I was also wondering because of time.
Yeah, I think we're done, or so.
Yeah. So should we maybe wrap up? I'm not sure how much.
Yeah, let's wrap up. Just to finish off, the economics are not really addressed that much yet, so that needs more study. And basically now I was already coming to the end, sorry. So, and basically I think we already discussed it, so I don't need to repeat this. But I hope that you now understand the role of packaging a bit better, and how we can actually reduce the environmental footprint of that. And with that, I would like to thank you for your attention. And I want to end with Kelvin and Hobbes, and to keep you thinking, and how that we really are not that smart. Yes.
Thank you so much.
You're welcome. Is there any other questions or items for discussion? So now will be the time. And if not, I wish you good luck with the project. And I hope that some of this that we discussed today can help you with that. Or if there are really specific questions to Mitra, then yeah, you can pass them on later on. Hopefully we can help with that.
Yeah, so I see that there are no more questions for now. And if there are some questions popping up later, maybe we can gather them and check with you if you have the time to get back on these. But I think we already shared so much information and input and examples that students can definitely use in their prototypes on which they're working now. And also the slides are and the presentation is going to be online, so they can also go back if they need more information.
Good.
So thank you so much for your time and for sharing everything with us.